This video is going to briefly run through some of the limit laws and properties of limits. So I'm going to start by giving you two different properties of limits. The first one says, limit as x goes to c of b, where b is a constant, equals b. So the limit of a constant is the constant. And so I have graphed a constant function. That's just going to be a horizontal line. So I have on the graph the function y equals 3. And we can see that when we have a constant function, no matter what x value we approach, for any c value, our y value is always going to be that constant. So there's our first property. The limit of a constant function is the constant, no matter where you approach. My second property says the limit as x goes to c of x equals c. And I have graphed to the right the line y equals x. On the line y equals x, the x and y values are always the same. This line goes through the point 1, 1, 2, 2, 3, 3, etc. And so what this property is saying is that anywhere on this line, if you find the limit as x approaches, for example, 3, the y values are also approaching 3. So the limit of x as x approaches c is always going to be c. Basically saying that x and y values are going to be the same. So we're going to start with these two basic properties and a bunch of laws of limits, and we'll see how we can put this together to solve other problems that involve limits. So my list of properties says, if we know what the limit of f of x is, and it equals L, and we know what the limit of g of x is, and that is k, then we can find limits of combinations of these functions. If we take the limit of a constant times f, we're going to get that constant times L. So this is saying you take the limit of a constant times a function, you get the constant times the limit. The second property says if you take the limit of a sum or a difference of functions, you're going to get the sum or the difference of those limits. So in a sense, this is saying you can find the limit of each piece separately and then add or subtract them to find the limit of that sum or difference. If you want to find the limit of a product, the limit of f times g, that's going to be L times k. So this is saying if you want to find the limit of a product, you can find the limit of each piece and then multiply those answers together. Same idea for the limit of a quotient. The limit of f divided by g is L divided by k, assuming that k does not equal 0, so we don't have some domain issue. And then finally, if we want to take the limit of f raised to the n, that's going to be L raised to the n. So basically what this list of properties is saying is that when we have combinations of functions, we can find the limit of each piece separately and then do the operation, whether it's addition, subtraction, multiplication, division, etc. So let's see how this works by trying to find the limit as x goes to 2 of 3x squared minus 5x plus 2. In this problem, I have a difference and a sum. So I have sum and differences of terms. So I can find the limit of each term and then add or subtract those limits together. So I can find the limit as x goes to 2 of 3x squared, and then minus the limit as x goes to 2 of 5x, plus limit as x goes to 2 of 2. Within each of these terms, there is a product, and I can find the limit of each piece in the product separately and then multiply them together. So the first term was 3x squared. To find the limit of 3x squared, we can find the limit of 3 and then multiply that by the limit of x squared. Same idea, if I want to find the limit of 5x, I can find the limit of 5 and then multiply that by the limit of x. And then finally, the limit of that x squared we have an exponent, and there's a property that says we can find the limit of x and then square that result. So then let's go ahead and find these limits. The limit of a constant is just a constant. So limit as x goes to 2 of 3 is just 3. The limit of x is the x value. So limit as x goes to 2 of x should be 2. So we've got 3, 2 squared, minus limit as x goes to 2 of 5 is 5. That's a constant. Times limit as x goes to 2 of x is going to be 2. And then finally, plus limit as x goes to 2 of 2 is 2. Another constant right there. So I'd like you to notice what happened here when we applied these limit properties. We're left with 3 times 2 squared minus 5 times 2 plus 2. I've essentially just plugged 2 into my function. 3 times 2 squared minus 5 times 2 plus 2. All right, and we can do this arithmetic. That's going to be 12 minus 10 plus 2, and that would be 4. So my final answer is 4. Now again, noticing that I've just plugged my x value 2 into my function, and that gave me the correct answer, let's actually say a little bit more about that. And in fact, we have some substitution theorems that basically are saying, just to summarize them, that if we're dealing with a polynomial, a rational function, so that's an algebraic fraction, a radical function, a trig function, a log function, or an exponential function, as long as we're working within the domain of that function, as long as the function is defined at x equal a, then we can find the limit as x goes to a of f of x by just plugging a in. In other words, if there's no issue plugging the number in, like dividing by 0, taking the square root of a negative, if the number we're working with is in the domain of our function, and we have a polynomial, a rational function, a radical function, a trig function, a log, or an exponential, then the limit is just the value we get by substitution. We can just simply plug the x value in. So for example, if I want to find the limit as x goes to 3 of the square root of x squared plus 5x minus 2, I'm going to start by just plugging this x value in. That gives me the square root of 3 squared plus 5 times 3 minus 2, or square root of 22. And that's my answer. It's as simple as just plugging the x value in. Now, sometimes we are going to plug x values in, and we are going to get an issue like division by 0. And fortunately, we're going to have other strategies that are going to allow us to deal with that. I'm going to save those other strategies for my next video. So that is it for this quick overview about properties of limits. Please let me know if you have any questions.